reaction you're looking at. We're only going to look at 6 types of reactions. The first one is the combustion reaction. So you should have your notes out in front of you. This is the back side of the notes that had the symbols with the arrow and the gas and aqueous, etc. So find the back side of that notes to find this table. Let's first look at combustion reaction. It says a hydrocarbon. This is a hydrocarbon because it has hydrogen and carbon plus oxygen produces carbon dioxide and water. So whenever you see that combination of exactly C something H something plus exactly oxygen forming exactly carbon dioxide and water, we call that combustion. For example, you might see this reaction. This is methane, CH4 plus O2, and CH4 is my hydrocarbon because it's C something H something, plus oxygen forming carbon dioxide and water. And that's just one example of a combustion reaction. So if you look at your note sheet, look just below this table, right down below, there's a bunch of examples of reactions. They're numbered, let's see, 1 through 8. Look down that list of reactions and try to find an example, 1 or 2 examples of combustion. Pause the video, and when you find it, unpause the video. An example of combustion reaction is seen on question number 4 on that list of reactions, and that's the only one. You might have thought one might be a combustion, but that's a different type of reaction. And you do see oxygen in the reactant side, but you don't see carbon dioxide and water in the products, so that one wouldn't count. Moving on, let's look at the second type of reaction, synthesis. It says the combination, also known as combination reaction, it's when 2 or more reactants form only one product. Circle this one product part because that's really important. So you see there's more than one reactant on the left side, but once you look at the products, there's only one thing there. 2 things make one. That's a synthesis reaction. Here's an example. So write this example in your notes. For example, nitrogen gas plus hydrogen gas. I'm using Humphrey-Burkle here because they're in Humphrey-Burkle. We're going to put, they like to make diatomic molecules. Makes ammonia and H3. This is only one product. Ammonia is one product, so that is a synthesis reaction. Look at the example reactions and find the synthesis reaction. Pause the video and unpause when you're ready to check your answer. You should have found the synthesis examples are number 1, because example 1 only has one product, and also number 8 is another example of synthesis because there's only one product on question 8 as well. Moving on to decomposition. One reactant, circle that part, that's important. One reactant forms 2 or more products. To decompose means to break down or to rot. So if I look at a reaction and I see there's only one reactant and I have more than one product, that is decomposition. An example, potassium chlorate, KClO3, decomposes to form potassium chloride, KCl, and oxygen gas. So, pause the video, look for an example of this, and unpause when you're ready. You should have found that number 2 in the example list is an example of decomposition, and so is number 3. Both of those are decomposition reactions. Moving on, displacement reaction, also known as single replacement, where an element in a compound switch either anions or cations. Remember, in a reaction, the cation is first, so A is a cation and B is a cation in those compounds. Same thing on the right side, A is the cation. Okay, so cations always come first in a compound, and anions are the second element in the compound. So X is an anion, X is an anion, X is an anion, and Y is an anion. So what you're looking for in a single replacement reaction is, notice this AX, that is a compound, it's more than one element. So you're looking for a compound plus, see this B right here, that's representing a single element. So we're going to call that a compound in a single will make another compound and another single. The same goes for this example on the right. Compound single make compound and single. Now what I mean by cation or anion switches, if we look at the example right here, in my compound AX, in the reactants I end up with BX in the products. X remains the same between both compounds. Therefore, the anion has not changed at all. It's the cation, the front, that's changed. So the cation is switched here. You should probably write that down. The cat has switched on the first reaction. Then on the second reaction, take a look at that. A remains the same on both compounds, but the anion has switched from X to Y. So this is an example of the anion switching. And this will come in handy later when we have to predict the products of a reaction. So here's an example of a single replacement. For example, how about, let's make sodium chloride. This wouldn't really happen in reality, but this is a good example just to show what type of reaction it would make if it did react. So I have a compound and a single, sodium chloride and potassium, making another compound, KCl, and another single. Compound, single, make compound and single. So in this case, you can look at the compounds to decide what's switched, cation or anion. And you would see, since chlorine's the same in both, it's the cation that switched in the example I just did. So go to your example reactions and find one or two reactions that is a single replacement. Pause and unpause when you're ready to come back. So you should have found a single replacement reaction on number 7, and only number 7 is an example of single replacement. Let's look at double replacement next. It says two compounds switch cations or anions to form two new compounds. Bottom line, you've got a compound plus a compound, making another compound and another compound. It's compounds all around. But don't look for an example yet on your note sheet because it's very easy to confuse double replacement with number 6 neutralization here. So let me finish the double replacement reaction. For example, how about potassium chlorate or potassium chloride reacting with sodium chlorate. So we got a compound and a compound, and we're going to make sodium chloride, NaCl, another compound, plus potassium chlorate, KClO3. We have a compound and a compound, making a compound and a compound. Number 6, neutralization, looks real similar because you're going to see a compound and a compound, making a compound and a compound. However, I have real specific compounds here in neutralization. It says an acid. And an acid is something that begins with hydrogen, except for water. So like H2SO4 or HCl or HNO3, those are acids. And a base, usually seen as something with hydroxide in it, OH. Specifically in the reactants, you're going to see those two compounds, one that begins with hydrogen and one that has hydroxide in it. Then in the products, you will definitely see water and then a salt. And we tend to think of salts as just NaCl, but there's more than just NaCl as a salt. Here's an example of neutralization. How about calcium hydroxide, Ca parentheses OH parentheses 2, calcium hydroxide. There's the hydroxide part of the reaction, plus sulfuric acid, H2SO4. That's an acid because it begins with hydrogen, producing water. That's a specific product of neutralization, water. And the salt, a salt is anything that's a product of an acid-base reaction. In this case, the salt will be calcium sulfate, CaSO4. And it's just because when an acid and base react, they form water, and the other product is a salt. So this is the acid, this is the base, here's the water, and finally that's my salt. It is compound and compound making a compound and a compound, but again, neutralization specifies you have an acid and a base reacting together to form that H2O and salt.